So what I have here is I have a piece of wood and a piece of copper. Nothing on either side of these. And what I'm going to do is I'm going to show you a little demonstration of electromagnetic induction and electromagnetism at work. So if I take this magnet and slide it down the wood, you see what happens. It slides down just like you would think it would. But when I take this piece of copper, which by the way is a conductor, and I slide the magnet down the copper, see what happens? Isn't that amazing? And if I stand it up higher, well, then it rolls off, but I wonder, what causes this to happen? So here's what we know from this lesson. As a conductor passes through a magnetic field, that magnetic field will induce a voltage or current into that conductor. The same can be true for a magnetic field passing over a conductor, as was demonstrated in my last video. We also know from the magnetism lesson that as current flows through a conductor, a magnetic field develops around that conductor. So here's what's happening in that copper plate. So when I place the magnet onto the copper plate, initially there's a little current there that is developed because I've brought that magnet close to the conductor. Once I let go of the magnet begins to slide down the copper plate. The moment I have motion, because now I've got the three requirements met, I've got a conductor, I've got a magnetic field, and I have relative motion. Once I have the motion of that magnet moving, then it induces a current into that copper plate. Now that current is in what we call an eddy current. It just kind of swirls, and because of the flow of that current, it's inducing a magnetic field in opposition to the magnetic field of the magnet. So as the magnet slides down, it induces a current, which induces an opposing magnetic field, which causes the magnet to stop ever so slightly, just long enough for the magnetic field induced by the current to stop or collapse. Once that collapses, the magnet is able to move again, and the moment it begins to move, it induces another current, which induces another opposing magnetic field, which causes the magnet to stop ever so slightly, and it does this all the way down, which is why we have the slow motion. So there we have it. We have electromagnetism and electromagnetic induction at work.